So this video is on definite integrals. So in starting this unit, we're going to talk about not just doing an integral with the plus c at the end, but we're going to give you a bounded region, and you're going to use that to find the actual integral. So you're going to get actual numerical answers. If I look at this right here, it says that the area under the curve is the integral of the function of this guy from A to B. So that tells you almost like your bounds. It tells you from where to where. The fundamental theorem of calculus, which is as big as it sounds, is when you take the integral of a function, now the integral of f of x is f of x plus c. Well, now when you put these bounds on here, you're going to find the integral of b, the upper limit, minus the integral of a. And there's not going to be a plus c. This is a very specific integral. I'm going to do these examples at a pretty quick clip. So if you need to, pause the video, rewind, go back and watch it a couple times, watch it once so you can write it down, and then watch it again so that you can understand it. But feel free to just use the video so that it's beneficial to you. Okay, so if I'm looking at this function, I know that this is a parabola that opens down. It tells me that it wants me to find the area from 0 to 4, which are his x-intercepts. So what I'm going to do is I'm going to take the integral of him, which would be 4 over 2 x squared minus 1/3 x cubed, and I'm going to simplify that. But instead of the plus c, I now have this bar, which tells me that I want to evaluate it from 0 to 4. So I'm going to plug in the bigger number first, and then I'm going to subtract the integral of the smaller part, or it evaluated at the smaller number, which is 0. The brackets, I think, are important, not so much on the front part because there's nothing going through it, but right here, this minus, make sure you have the whole second part in brackets or parentheses. 4 squared is 16. 16 times 2 is 32. 4 cubed is 64. And then all of that is going to be a 0, which is really nice. I want to put this over 3. So 96. And then subtract 32/3. Units squared because it was specifically talking about the area under that curve. So as you can see, when we have a definite integral, we're going to get an actual answer, like a numerical answer. Okay, so on these, taking the integral is old. That's now a step in this process. So that's unit 6. It's the evaluating part that's new. So the integral of 4 is going to be 4x. Normally you would put the plus c, but here you're going to put the evaluated from 3 to 1. So you're going to do 4 times the upper limit minus 4 times the lower limit, which is 8. And again, if this goes too fast, I want you to pause it after each problem so that your brain can wrap around whatever it needs to wrap around before you move on to another example. Okay, if I do the integral of this one, so I'm going to plug in a 3, and then I'm going to plug in a 0. So 9 over 2 plus 6, and the whole back end is going to be a 0. That's 12 over 2, so 21/2. This next one is going to be 1/3 x cubed minus 3x from 1 to 2. So I'm going to plug in a 2 and get 8/3 minus 6 minus, and this is important, parentheses, plug in a 1, that would be 1/3 minus 3. If I put this guy over 1, that'd be 18/3. So that's a negative 10/3. And if I put him over 1, that's a negative 8/3. But remember, there's a minus here. So that gives me a negative 2/3. Okay, so for this one, I hope you can see that this would be U substitution. I'm going to let my U be what's on the denominator and just see how it plays out. So this looks good. He just needs a negative 3, so I'm going to balance it with a negative 1/3. So I have negative 1/3 integral from 2 to 4 of du over u. And so that's ln of the absolute value of u, which would be 5 minus 3x. And I'm going to go from 2 to 4. Okay, when you have this out front, I'm going to do this. And then ln, see if I plug in a 4, 5 minus 12 is a negative 7. Absolute value would be 7. And then minus, now I'm going to plug in a 2. That's a 6, so that's a negative 1. So positive 1, absolute value. Okay, so they could stop here, but they're probably not going to. They're going to do this, and then they're going to force you to remember your expansion and condensing rules with logs, and remember that when it's subtracting, that condenses to division. So this is actually ln of 7 over 1, which is just 7. So that's how you get that. And then this number that's out front is going to become a power for your 7. That's another one of those expanding and condensing rules. So then that could be written as this. So in all honesty, they could have this answer, they could have this answer, they could have that one, or they could have this one. They can't have all of them or 2 of them because they're all correct. You just have to be able to go as far as they go. Number 5. Let's see. I'm going to let my u be the power. So the derivative of that. So we need a negative. So I have negative integral negative 1 to 0 of e to the u du. And the integral of e to the u is just e to the u. And I'm going from negative 1 to 0. So I have negative e to the 0 minus a negative e to the negative 1. And you could have left this negative out like we did the negative 1/3 and done it this way, e to the 0 minus e to the negative 1. That would have been fine too. E to the 0 is 1, and e to the negative 1 is 1 over e. And then common denominator. But then you have this negative 1 out here, which would make it 1 minus e. If you run that negative through, that would make the e negative and the 1 positive, and then flip it around and put the positive 1 in the front. So odds are what's circled would be what your answer is. Number 6, secant squared. So you've got to remember that secant squared is the result of the derivative of tangent. So then the antiderivative of secant squared would just be tangent. So no u sub needed, just have to know those derivative rules and then think backwards. And I'm going from 0 to pi over 4, so I have tangent of pi over 4 minus tangent of 0. Pi over 4, that's the root 2 over 2, root 2 over 2, so tangent of that would be 1 because it's y over x. And then tangent of 0 is y over x, so that would be a 0, which is 1. Okay, so for number 7, when you have two trig functions, you're going to let your u be the trig that has the stuff being done to it. So that's going to be the cosine. The derivative of cosine is negative sine. So we need a negative. So now I have negative integral 0 to pi over 2 of u squared du. So negative 1/3 u cubed. So negative 1/3 cosine cubed from 0 to pi over 2. So negative 1/3. All right, if I plug a pi over 2, pi over 2 is north, 0, 1, cosine 0, so that would be a 0, minus, now I'm plugging in a 0, and that would be a 1. And notice I keep my negative 1/3 out front. So now I have a negative 1/3 times a negative 1, got a positive 1/3. Okay, number 8's got all kinds of fun stuff. I see the stuff out front. I also kind of acknowledge that that's a double angle. I'm going to hold off on that for a little bit. I'm going to let my u be my power on my e and just see how this shakes out. So if I let my u, so the derivative, so this is going to be a turduck. So the outside is the power, and the inside is the trig. So the derivative of sine is cosine. Okay, now this is this. That's the double angle formula. Like they are equal to each other. So I have what I need. So I have the integral of 0 to pi over 2 of e to the u du. So when I integrate that, that's going to give me e to the u, which is e to the sine squared x from 0 to pi over 2. Okay, so this is going to be e to the sine squared of pi over 2. Well, sine of pi over 2 is the y value. That's a 1. 1 squared is 1. And then e to the sine squared of 0, well, sine squared of 0 is 0. Sine of 0 is 0. 0 squared is 0, so that's e to the 0. So that would be e minus 1. Not as bad as it looked. Number 9. Cotangent, just a plain cotangent. That's one of those integral rules you have to have memorized. I remember it because cotangent is sine over cosine, and it's always the denominator. It does, let's see, so it's ln of cosine, and that is a c, so it's going to be negative. And I'm going from pi over 6 to pi over 2. I'm going to leave this negative out and do my ln of cosine of pi over 2 minus ln of cosine of pi over 6. And I could do some of this in my head. I'm just going to write it out. Okay, cosine pi over 2, that's x. That's a 0. So ln of 0 minus ln, all right, pi over 6 is the little one, and that's ugly, pretty. Yeah, ugly, pretty. So that would be, all right, hold on. Dang it. All right, I just did this. I did this wrong because cotangent is not sine over cosine. That's tangent. Shoot. All right, all the way back to the beginning. Cotangent is not sine over cosine. It's cosine over sine, which makes this guy a sine, which is an s, which makes it not negative. And these are sines, not cosines. Shoot. Sorry. Okay. So feel free to hit pause and fix and get back where we are. Okay, so sine of pi over 2 is going to be a 1. And sine of pi over 6, sine is the y value, and that's a 1/2. So then if I condense, I have 1 over 1/2, and if you same change flip, you get ln of 2. Okay, and again, apologies for missing the trig at the very beginning. All right, number 10 and number 11 both make me think maybe it's an inverse trig. I'm going to use U-sub to start with and see how it plays out. This one has an x on top, which makes me think, yeah, he just needs a 2 and a 1/2. So he's 1/2 of u to the negative 1/2 du. Okay, so if I add 1, that's a 1/2. This 1/2 is just this one being brought down. Negative 1 plus, or negative 1/2 plus 1 is a 1/2, and then you flip it, that's a 2. U to the 1/2. So those cancel. So I have x squared plus 9 to the 1/2 from 0 to 4. So if I plug in a 4, squared is 16 plus 9 is 25, and square root it, that's a 5. Plug in a 0, that's a 9. Square root it, that's a 3. And subtract, that's a 2. All right. This one's, if you start with U-sub, which is fine, when you do your du, remember you can fabricate a negative. I already have the 2, which is nice, but I cannot fabricate that x. So this can't be, that can't be my u. And this is the integral of inverse sine. So if we do the integral, it's du over the square root of a squared minus u squared equals inverse trig of u over a plus c. So here my a squared is a 1, my u squared is x squared. So my a is 1, my u is x, and my du is a 1 dx, which means I don't need anything, but it also means I have an extra 2. So I'm going to pull this guy out just so he's out of the way. And this is going to give me sine inverse of u over a, so x from 0 to 1/2. Okay, now notice I kept the 2 out front with brackets. He can't just go to the first term. He's got to go to both. If you want to write him in front of both terms, that's fine, but I have formed the habit where I'll put him out front with a bracket. Do what's inside the parentheses or the brackets, and then put the 2 on it. So let's make sure we're super clear on what sine inverse of 1/2 means. That means what angle, there's an angle somewhere where sine of that angle is a 1/2. So this would have to come from the point ugly pretty, because the sine is the y value, and ugly pretty are going to be in the first and the third quadrant. So that's going to be pi over 6 or 5 pi over 6. If you go down here, that y value will become negative. And we're just going to use the smaller one. Sine of something is 0. If you look at this point right here, that's 1, 0. So that's where sine is 0. So that angle is 0. So then that gives me pi over 3. Okay. All right, it says let f of x equal cotangent x dx. X is in between 0 and pi. And then it says if f of pi over 6 is 1, find f of 1. Okay, now notice this is not a definite integral because it does not have a lower and an upper bound. So if I'm going to integrate this, I'm going to have the plus c. And the integral of cotangent, let's see if I can get my trig right this time. Cotangent is cosine over sine. So it's ln of sine of x plus c. And I'm going to write y equals because I'm about to plug in an x and a y. So f of pi over 6, that's my x, and my y is 1. And then to solve for c, I'm just going to subtract this over. So I'm going to use my calculator and get a decimal. So I'm going to make sure I'm in radians, and I'm going to do 1 minus ln sine of pi over 6. And you're going to get 1.693. So that's my c. So now I'm y equals ln of sine of x plus 1.693. And now it's asking for f of 1, which means plug a 1 in for sine. And so I'm just going to straight up type this into my calculator. So I'm going to type in ln of sine of 1, close all your of parentheses, and then plus 1.693. So I would practice typing that in and making sure that you get the correct decimal. Okay, this one is just a tad bit different because there is an x in my upper bound. So this is still a definite integral, but it has a new variable in my upper bound. So this is all in relation to t, and my upper interval has an x on it. So I'm going to do a little u sub and let my u be my of. So we need the 2, so I'm going to bounce it with a 1/2. So I have 1/2 integral of cosine of u du from pi over 4 to x. So now I'm ready to integrate that, and the integral of cosine is just plain sine. So 1/2 sine of u. I'm going to put my u back in there. And I'm going to go from pi over 4 to x. So now I'm just going to plug in an x. Minus, all right, 2 times pi over 4 is going to give me pi over 2. Sine of pi over 2 is 1. And then I'm just going to write it all over 2 instead of the 1/2 out front. But, I mean, you can write it either way. It's fine. Multiple choice, just be flexible. So the x didn't cause us to do anything different. It just kept us from getting a numerical answer. We have an expression as our answer that has an x in it. Number 14, what are all the values of x, and x is my lower bound, where the integral is equal to 0? So first, let's start by taking the integral. So that's going to be 1/4 t to the 4. And I'm going to go, nope, not plus c. I'm going to go from x to 2. Then I'm going to plug in my 2. So 1/4. 2 to the 4th is 16 minus x to the 4th. I'm just plugging in my x. But then it tells me what it wants it to equal. So I want it to equal 0. So now all I'm going to do is solve for x. Well, the first thing I'm going to do, I'm not going to distribute my 1/4. I'm going to multiply both sides by 4 and let him cancel. And then I'm going to add my x to the 4th over. And then I'm going to 4th root both sides and get plus or minus 2. Because the cube root of, or the 2 cubed is 8, so 2 to the 4th is 16. And it's kind of alluding to the fact that you could have more than one answer there. What are all the values of x? So don't forget your plus or minus, because you know if it was multiple choice, positive 2 would be choice A. Okay, and then the last one, this is a piecewise function. So f of x, it's broken into 3 different pieces. I want the integral from -1 to 1. From -1 to 1. So think about it. This is a quadratic to 0. This is a dot. And then I'm linear anytime I go bigger than 0. But again, guys, this is just a dot. Remember that the integral is the area under the curve. Well, this middle piece is just a dot. It's just where these two pieces kind of shift gears. So when I do this, I'm going to do an integral. Let's see, I'm going to go from -1 to 0, and then I'm going to do another integral where I go from 0 to 1, because that's where these two things break. So which function do I want? Which function is on this left-hand side from -1 to 0? And that's this guy right here, because these are all the x's that are less than 0. And then from 0 to 1, it's going to be this guy. And you always want to have good notation. Don't forget your dx. And then I'm just going to integrate. And I'm going to integrate this guy. And then I'm going to evaluate. So plug in a 0, I get a 0. And then minus 1/3 times -1. So that's a positive 1/3. And then here I'm going to plug in a 1 and get a 1/2. And then I'm going to plug in a 0. So 1/3 plus 1/2. So 5/6 units squared. Okay, and again, I know I went fast, and I know I made a mistake, but so again, feel free to go back and just watch and let it sink in until you feel good about it.